Today we're going to take a look at inverse functions. So to start off today, there is a review of composition of functions. So pause the video and then start it once you have finished this review. So again, we have g of f of x if we were to write it with this notation. And our outside function is that g of x, x squared plus 1. So we'll replace that x with our f. So we have 5x squared plus 1. So we have 25x squared plus 1. So what we're going to do today is take a look at inverse functions. The inverse of a function, so here's our function, and then this is the notation for an inverse. It reverses the action of that function. So, for example, if we have the coordinate 3, 4, if this is the inverse of it, if there's a point, our inverse, it reverses the action, it's going to be 4, 3. So those x and y values switch. So our x and y are the inverses. So what we can do is we can pick any positive value for x. So let's say we have x equals 3, and we can plug it in. So we have 3 times 3 minus 4. 9 minus 4 is 5. So we end up with y equals 5. So to see if it's an inverse, we'll plug in 5 for our x value. So we have 5 plus 4 over 3. 9 divided by 3 equals 3. So they undo each other. If we take our y value and plug it back in, so in this one, the coordinate 3, 5. In this one, it's the coordinate 5, 3. But the key here is that it has to work for every function, or for every coordinate. So when we take a look at this one, we're going to test these two. So let's try x equals 3. So 3 squared minus 4. 9 minus 4, we end up with y equals 5. So over here, we're going to plug in when x equals 5. So we end up with the square root of 5 minus 4, so y equals 3. So this one, again, we had the coordinate 3, 5. And over here, we had the coordinate 5, 3. So that works. But let's try a negative. Let's try when x equals negative 3. So we have negative 3 squared minus 4. Well, once again, that's y equals 5. But we already know when we plug in 5, we get 3. So it doesn't work for positives and negatives here. Let's try another negative. Let's try what happens when x equals negative 4. Negative 4 squared minus 4, so 16 minus 4, y gives us 12. So when we plug in 12, we get the square root of 12 plus 4. So we're plugging in when x equals 12 now. And the square root of 16 is 4. So it doesn't always work. So not all functions will so this one is not the inverse of this function over here. Now we're going to talk about how you get these from ordered pairs or graphs. So it's pretty easy here. We can just rewrite this. 2, 1, 5, 3, and 8, 5. There's our inverse. So from a graph, we can write out some coordinates here. So we have the coordinate 0, 0, 1, 1, negative 1, 1, negative 2, 1, 2, 3, 4, negative 2, 4, and 2, 4. So if we switch these, we still have 0, 0, we still have 1, 1, but we have 1, negative 1, 4, negative 2, 4, and 2. So 0, 0, 1, 1, 1, negative 1, 1, 2, 3, 4, and 2, and 4 and negative 2. So it looks like here our parabola turned on its side here. Now, is the inverse a function? I'm going to say no, because it doesn't pass that vertical line test. Now, one other thing to note here, if I was to draw in the line y equals x, this inverse, it's a reflection over the line y equals x. So you can always take note and see if you did it right by drawing in that line y equals x, and then if you were to fold it in half, would that graph match up? Now let's say we are asked to find the inverse here. Well, let's take a look here. We don't know what it is. We have to find it. So first thing, I'm going to rewrite this. Y equals 3x minus 2. And what we can do is we can switch x and y, because that's what we were doing with our coordinates, and then we have to solve for y. So we have x equals 3y minus 2. So solve for y, we add 2. So we have x plus 2 equals 3y, and then we divide by 3. And usually you'll see it for the inverse notation. Instead of y, we're going to say that that's that inverse, so we use the f inverse notation. And then we can check to see if it's correct. So we could check it by graphing. We could look at that. We could switch points. And then we're going to take a look at one other method as well. So these are two that we could check to make sure we did it right. And then on this one here, what we're going to do is we're actually going to see how it works. So again, take a minute, pause it, and I want you to find the inverse. So hopefully you started, I always replace it with y, so then we change our y and x. So we have x minus 4 equals negative 3y divided by negative 3. So we have our inverse equals x minus 4 divided by negative 3. Now to show that it's an inverse again, let's take a look, and we can take a look at the graphs. So we had 4 minus 3x, and then if we tab again, our second one, x minus 4 over negative 3. There's our other one, and let's see, what I'm going to do is I'm just going to draw in the line y equals x, and it is, and it's a reflection right over there. We could go Control T and bring up a table here, and we could take a look through that table as well, and that could help us. And we could take a look and make sure those coordinates switch there. So let's see, we have, for example, we have negative 210, so that means down here we better have a 10, negative 2, and we could double check a couple points that way. One way we can do it without graphing or checking ordered pairs is we can check for what's called the identity function. And that means if we do this composition of f and its inverse and out comes x, then f and f and the inverse, they are inverses of each other if we do the composition and x comes out. So let's take a look at this one. We're asked to find the inverse. So we have y equals x over 3 plus x. So we switch them. So we have x equals y over 3 plus x. 3 plus y, excuse me. So this one's a little tricky. So let's see. We want to get the y's out of the denominator. So we can cross multiply. X times 3 plus y equals y. So we have 3x plus xy equals y. Well, let's get the y's on the same side. So 3x equals y minus xy. If we factor out a y, we have y times 1 minus x. Then we can divide by 1 minus x. So 3x over 1 minus x equals our inverse. Now to double check and see this, remember we have to do f, the composition of f with our inverse. So in our outside function here, oh, this one's going to get a little messy to check. We need to replace our x with 3x over 1 minus x divided by 3 plus 3x over 1 minus x. And then we have to simplify. And this one is a mess to take a look here. I think we're going to go back and take a look at the example before. And this does work out here. But there's a lot of algebra in here, and I want you to see how this works. So let's take a look back at this one. I'm going to show you how this works. Sorry about that, guys. When we take the composition. So our outside function, our f function, was 4 minus 3x. We'll replace that x with our inside one, so we have 4 minus 3x minus 4 over negative 3. And we can distribute, and we distribute to the numerator, so minus 3x plus 12 over negative 3. Alright, and then we can divide both of these by 3, so we have 4 plus x minus 4, and we notice 4 minus 4 gives us x. So this one's a little messy as well, but you can see if you do that algebra, out will come an x. Now we have to find the inverse on this one. So we switch the x and y, so x equals 1 over y minus 2. Well, let's see, we can add 2, so x plus 2 equals 1 over y, multiply by y. So we have y times x plus 2 equals 1, and then we have to divide by x plus 2. So our inverse is 1 over x plus 2. And the third type, just as a reminder, let's say we had g of x equals the cubed root of x plus 5. So we switch our x and y. X equals the cubed root of y plus 5. Subtract our 5. And then hopefully you remember to get rid of a cubed, you raise it to the power of 3. So we have x minus 5 to the third equals y. And then we need to check to see if it is a function. We could just graph these and see if it is a function. So that one there, let's see, I'm going to go doc B. So we have 1 over x plus 2. And it passes the vertical line test, so it's a function.